Okay, so in this example, we're going to look at calculating the speed of a satellite. And the example says, calculate the speed of a satellite moving in a stable circular orbit around the Earth at an altitude of 3,600 kilometers. Okay, so if you remember, what we had discussed was that when you have a circular orbit, the centripetal force is caused by gravity. And I had gone through the derivation here, but this concept leads us to this expression, G, mass of the planet, over R. So we're going to use this to calculate the speed. So I need to know the mass of the Earth, which is 5.98 times 10 to the 24th, not something you need to memorize. And I need to know the radius of the orbit. Now, an important note, guys, is it tells us in the problem that the altitude above the Earth's surface is 3,600 kilometers. If you look at the picture, the radius of this orbit is not 3,600 kilometers. It's the 3,600 kilometers plus whatever the radius of the Earth itself is. All right, so to get R for my equation, I need to do the radius of the Earth plus the altitude, h. So that's going to be 6.38 times 10 to the 6th meters. That's the radius of the Earth, plus the 6,300, or 3,600, excuse me. However, this is written in kilometers. I need to convert that to meters. So you need to multiply that by 1,000 to get it in meters before you begin. So if I multiply 3,600 by 1,000, I get 3.6 times 10 to the 5th meters. So the overall R is the sum of those two numbers, 6.38 times 10 to the 6th plus 3.6 times 10 to the 5th. Gives me 6.74 times 10 to the 6th meters. Put the meters here. Okay. So now I'm ready to go. B equals square root. G is 6.67 times 10 to the negative 11th. M is 5.98 times 10 to the 24th kilograms. And R, 6.74 times 10 to the 6th meters. So if I do this, 6.67 E negative 11 times 5.98 E 24 divided by 6.74 E 6, and I take the square root. I'm getting 7,693 meters per second. That seems like a reasonable answer for me because we had said in class that at the surface of the Earth, the speed would have to be around 8,000 meters per second. You're a little bit farther away from the Earth's surface, so the speed would be a little bit less.